All right, guys, watch and listen carefully here. So for question number 1, I have a catapult that launches a 50-kilogram rock at a speed of 29 meters per second. If the catapult was drawn back 3 meters, what force was used? All right, so give them 1 mark, okay, for their givens. What kind of energy is being changed about the rock? It's kinetic energy. When it's sitting in the catapult, it has none. When it leaves the catapult, it has a lot. All right, so we are looking at work being a change in kinetic energy. They can have a mark for that. All right, so what that's going to mean for us is that force times distance equals 1/2 mvf squared minus 1/2 mvi squared, but what's vi? 0, so we don't even need to write it, okay? 3rd mark there. All right, we're manipulating for force this time, so I need to move distance over to the other side. So I would divide both sides by distance, okay, and I'll be left with this, okay? That force equals 1/2 mvf squared, okay, divided by d, all right, which if they plugged in the numbers, looks like this: 1/2 times 50 times 29 squared divided by 3.0, so they can have their 4th mark for that. Okay, so in your calculator, we got 0.5 times 50 times 29 squared, okay, divided by 3. All right, we had to use 7,008 newtons worth of force. Fifth and final mark there. Questions on that one? Okay, how many work energy theorem questions have we done that work just like that? Lots, right? Like basically every one. If it's a kinetic energy question, that's how it works. Okay, we're either solving for force, we're solving for distance, or we're solving for speed. It's just a manipulation. All right, second question. Okay, we're looking for the height that a 0.250 kilogram rocket will reach if a force of 200 newtons is exerted on it over a distance of 4.5 meters. So if you ever built like a bottle rocket, okay, this is essentially what we're talking about here. Okay, the force of the expanding gases acts on it until the gases don't expand anymore, and then it just travels upwards until it runs out of steam. Okay, so we've got 1 mark for givens here, okay, and we've got that work in this case is changing what kind of energy? Potential energy. I mean, it is changing the kinetic energy as well, but that's not what they're asking us about. They're asking what's the maximum potential energy that we're going to have. Okay, so work equals the change in potential energy. I can have a mark for that. Force times distance equals m times g times h final minus m times g times h initial, but it's on the ground initially, so we don't need to worry about that part. Okay, and we are looking for the maximum height here, so we just need to divide, sorry, they get a mark for that. Then we need to divide both sides by m times g, okay, which will give us our final formula. So hf will equal force times distance divided by m times g. That's 200 times 4.5 divided by 0.250 times 9.81. So they can have a mark if they have something like that. Okay, our final height, 200 times 4.5. I can't believe we did. That's 900. Okay, divided by, in brackets, 0.250 times 9.81. All right, so we're looking at a maximum height here of 366.97 meters. Okay, if they rounded it to 367 meters, that's fine. Okay, so give them a mark out of 10, please. Let them see it, and then I'd like them in a nice, neat pile on this desk right here.